A trusted planetary climate model failed in complete silence when an entire layer of Venus's atmosphere simply stopped glowing. There was no explosion, no solar storm, no warning from deep space. One routine ultraviolet observation showed the familiar bright atmospheric crescent wrapping around Venus exactly as expected. On the very next orbital pass, half of that glowing hemisphere was gone. Not dimmer, gone. And the moment scientists saw that blackened section appear where one of the most stable atmospheric signatures on Venus was supposed to be, decades of assumptions about how the planet moves heat around itself suddenly became unreliable. Because this was not weather changing, this was the machine underneath the weather changing. For years, planetary scientists treated Venus's upper atmosphere as one of the most predictable systems in the inner solar system. Near the top of the atmosphere, roughly 70 miles above the surface, nitrogen and oxygen atoms constantly collide in the darkness of the planet's nightside. Those collisions produce nitric oxide, creating a faint ultraviolet glow invisible to human eyes, but perfectly measurable by orbital spectrometers. The process looked stable, reliable, almost mechanical. It had become one of the best tools scientists had for understanding how Venus redistributes heat from its sun-facing hemisphere to its permanently dark side. That faint glow became a map. A global indicator showing the planet's upper atmosphere was circulating energy exactly the way long-standing models predicted. Then the map disappeared. The first reaction was not scientific curiosity. It was instrument failure. Because the alternative was worse. The orbital spectrometer had been tracking Venus during what should have been an ordinary measurement cycle. Solar activity was quiet. No unusual radiation spikes were recorded. Calibration systems showed no obvious malfunction. But the spectral comparison images were impossible to ignore. A bright ultraviolet atmospheric crescent had collapsed into a nearly black hemisphere over consecutive passes. The signal had vanished so completely that engineers began checking whether the detector itself had physically degraded in orbit. Except the detector was working perfectly. And that changed what scientists were looking at. The original assumption had been simple. The glow tells us what the atmosphere is doing. Now the observation meant something very different. The atmosphere itself had abruptly reorganized. And that reinterpretation created a much bigger problem. Because Venus is not supposed to do that. Planetary circulation models had always assumed enormous stability. Venus rotates incredibly slowly. One full rotation takes longer than its entire orbit around the Sun. Yet despite this sluggish spin, the atmosphere races around the planet at hurricane speeds in a process called superrotation. The upper atmosphere moves heat globally like a giant conveyor system. That conveyor system was assumed to be steady. The nitric oxide glow was proof. Until it vanished. And suddenly, the glowing crescent scientists trusted for years stopped being evidence of atmospheric stability. It became evident that the atmosphere could silently shut down entire transport pathways without any visible sign from outside. Same image. Completely different meaning. At first, researchers thought they were looking at a temporary disturbance, perhaps localized turbulence. Maybe an unusual wave pattern moving through the upper atmosphere. A transient disruption. That explanation worked. For a while. Because when scientists reconstructed earlier orbital measurements, a disturbing pattern started appearing. Small fluctuations in the airglow had happened before. Tiny brightness shifts. Minor asymmetries. Brief irregularities no one considered important. At the time, they were dismissed as harmless noise. Now those old measurements looked very different. Those fluctuations were not random. They were warning signs. The bright ultraviolet crescent had been quietly signaling instability long before the complete shutdown happened. And that meant scientists had misunderstood what the glow represented for years. It was never proof of atmospheric equilibrium. It was evidence of a fragile balancing act. The midpoint of the story changed everything. Because now, this was no longer about a strange atmospheric anomaly. It was about whether every major Venus climate simulation had been built on a false assumption. The models treated upper atmospheric circulation like a stable engine. Input energy from the sun enters the system. Atmospheric currents transport that energy around the planet. Chemical reactions produce predictable nitric oxide emissions. But if the glow could disappear completely within days, the system was not stable. It was dynamic. Violently dynamic. And that created immediate engineering consequences. Future Venus probes depend heavily on atmospheric predictions. Entry vehicles experience brutal temperature gradients. Descent systems rely on expected pressure transitions. Aerodynamic heating calculations assume atmospheric transport models are correct. If the upper atmosphere can reorganize itself without warning, engineers lose predictive certainty. And suddenly, the visual anchor returned again. That same spectral image. The bright crescent scientists trusted. Then the black hemisphere replacing it. Earlier, that image looked like a failed detector. Later, it looked like atmospheric instability. Now it meant something worse. It meant future missions could encounter environmental conditions no model had predicted. The atmosphere was not slowly evolving. It was capable of rapid internal restructuring. Invisible restructuring. And planetary scientists rushed toward a new explanation. Global circulation models were rebuilt from scratch. Simulations began incorporating unstable vertical transport mechanisms, linking lower atmospheric pressure waves to upper atmospheric chemistry. The conclusion was unsettling. Energy transport on Venus was far more chaotic than anyone understood. Massive atmospheric currents were capable of shifting planetary-scale circulation patterns in real time. Entire chemical systems could shut off globally. Not over centuries. Not over decades. Over days. And suddenly, that final blackened ultraviolet image became something far larger than an atmospheric observation. It became evidence that one of the most studied planetary climate systems in the solar system was fundamentally misunderstood. Not because the planet changed. Because scientists misunderstood what stable ever meant. That glowing crescent on Venus had always looked permanent. Reliable. Predictable. Until one ordinary observation cycle proved the entire machine underneath it could silently rearrange itself whenever it wanted. And the dangerous part was simple. Nothing on the surface warned them first. The planet never needed permission to change. And neither did its atmosphere. The machine was never stable.